In the last episode, you learned how to use for loops to repeat actions. List comprehensions take that idea one step further. They let you build an entire list in a single clean line of code. In this episode, we go line by line through what they are, how they work, and how to use them with filters. Here is the traditional way to build a list using a for loop. We start with an empty list called squares. Then we loop through range 5, which gives us 0 through 4. On each pass, we calculate x squared and append it to the list. The result is a list of 5 squared values. This works perfectly fine, but it takes 3 lines just to build one simple list. List comprehensions solve that. A list comprehension produces the exact same result in one line. The syntax is an opening square bracket, then the expression you want to compute, then the for keyword, then your loop variable, then the in keyword, then the sequence, then a closing square bracket. Reading it left to right, compute x squared for each x in range 5. Python evaluates this and returns a complete list. The result is identical to the 3-line version. List comprehensions work with any sequence, not just numbers. Here we have a list of names in lowercase. We use a comprehension to call the upper method on each name. The expression on the left is name.upper. The loop variable is name, and the sequence is the names list. Python applies upper to each item and collects the results into a brand new list. The original names list is not changed. You can add a filter to a list comprehension using an if condition at the end. The structure becomes expression, for, variable, in, sequence, if, condition. Here, we loop through numbers 1 to 10. The condition is n modulo 2 equals 0, which is true only for even numbers. Python checks the condition for every item. Items that pass the condition are included in the new list. Items that fail are skipped. The result is a list of only the even numbers. Here are 2 more filtering examples. In the first, we loop through a list of words and keep only those with more than 4 characters. The len function checks the length of each word. Elephant and hippopotamus both pass. Cat, dog, and ant are filtered out. In the second example, we have a list of scores, and we keep only those that are 50 or above. The comprehension checks each score and includes only the passing ones in the result. You can transform and filter at the same time in one comprehension. Here, we want to square only the even numbers from 1 to 10. The expression on the left is n squared. The condition on the right filters to even numbers only. Python first checks if each number is even. If it is, it squares it and adds it to the result. The numbers 1, 3, 5, 7, and 9 fail the filter and are never squared. The result is the squares of 2, 4, 6, 8, and 10. A nested list comprehension uses 2 for clauses inside the same brackets. The first for acts as the outer loop and the second acts as the inner loop. Here we combine each number from 1, 2, 3 with each letter from A and B. For each number, Python loops through both letters and creates a pair. The result is 6 pairs in total. Nested comprehensions are powerful, but they become hard to read quickly. The 2 levels is generally the maximum you should use. List comprehensions are not always the right choice. They work best when the logic is simple and readable at a glance. When a comprehension has multiple conditions, complex expressions, or nested loops, it becomes harder to understand than a regular for loop. The example at the top works, but it is not immediately clear what it does. The loop version below is longer, but much easier to read and debug. In Python, clarity always beats cleverness. You now know how to build lists in a single line using comprehensions, how to filter items with conditions, how to transform and filter at the same time, and when to use a regular loop instead. In the next episode, we go deep into data structures, covering lists, tuples, dictionaries, and sets.